Hi everyone, and welcome back to Algebra 2. I'm Mrs. Stillwell, and I'll be covering our lesson for today. Please remember the rules of note-taking. If you see it on your screen, you should be writing it down in your notes. Some of you printed the notes out ahead of time, which will allow you to just watch the video and work through the examples. Feel free to add things in your own words so they're easier to study later on. Don't forget to hit pause and replay as often as you need to. This is especially true during the examples and the you try problems. Okay, here we go. We are covering today Chapter 3, Quadratic Equations and Complex Numbers. Section 4, using the quadratic formula. This is Part A. Our learning target is 3A. So we can solve quadratic equations by a variety of methods. Most of this is going to be a review, so we're going to go through it fairly quickly. Please remember you can replay this as often as you need to. Quadratic equations. Anything that has a power of 2 is a quadratic equation. Quadratic formula. X equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, where the a's and the b's and the c's all come from the actual original equation. Please notice they need to be in this order, or A and B and C won't be where you expect them to be. The only new thing that we're going to cover today, at least new for most of you, is called the discriminant. Now the discriminant is just part of the quadratic formula, this part right here. You can see it right here inside the square root. Notice this does not have a square root in it. We're not interested in that right now. And what the discriminant tells you is how many answers and what kind of answers you're going to get without having to do the entire quadratic formula. If the discriminant is positive, you're going to get 2 real roots, solutions, x-intercepts. Please remember, if you have 2 real roots, it's going to hit the x-axis twice. If the discriminant is equal to 0, that means you have 1 real root. Notice that's an asterisk right there because all the way at the bottom, it's called a double root. There's always 2 answers in quadratic equations. If you end up with the discriminant equal to 0, that means you have a double root. There are actually 2 answers. They just both happen to be exactly the same, which means you have 1 x-intercept. It's identical. Last but not least, if the discriminant is less than 0 or negative, you have 2 imaginary roots. Please notice it does not say x-intercepts. These are not x-intercepts here because they're imaginary, so they don't actually exist on a graph. These are called complex numbers, which you learned about earlier in this chapter. Okay, before we get to solving these things, please remember one thing. The equation has to be equal to 0 in order to use the quadratic formula. Okay, with that said, let's get started with some examples. Our first example, we have identified our A is 1, our B is -6, and our C is 4. The reason I can do that is because it's already equal to 0. Here I have the quadratic equation, and I'm about to plug in A, B, and C where they belong. So we have B is -6, B is -6, A is 1, C is 4, and A is 1. And we are ready to just simplify this. The opposite of a negative is a +6. -6 squared is 36. 4 times 1 times 4 is 16. And 2 times 1 is 2, which means we have 6 plus or minus the square root of 20 all over 2. Please remember from earlier when we practiced simplifying radicals, 20 is 2 times 2 times 5, which means that I can pull this 2 out, which will make it look like this. We are not done because that and that will reduce. 6 over 2 is 3. And 2 over 2 is 1, which just leaves that root 5. And we are finished. We expected 2 answers. Quadratics always have 2 answers, and we got exactly the 2 answers that we thought we were going to get. Next problem we have right there. Please notice that this is not equal to 0, which means I have to solve that problem by moving these across. Fortunately, just some basic algebra. And move this one across by adding 4. And once I am done with that, I'm going to have 25x squared minus 20x plus 4 is equal to 0. Please notice it has to be equal to 0 or this will not work. So we have A is 25, B is negative 20, C is 4, bigger numbers than we usually have. But we're just going to put them in where we see the blanks for them. And, oops, forgot to leave that a blank one. So that's a 25, sorry about that. So, solving the problem. The opposite of a negative 20 is a positive 20. Negative 20 squared is 400. 4 times 25 is 100, times 4 more is 400. And that's all over 2 times 25, which is 50. So I've got this. And of course we know the square root of 0 is 0, which means I actually just have this. Now please remember you need to reduce it all the way so I can cancel out the zeros, better known as dividing by 10, and I have 2 over 5. Now some of you are going to say, wait, you said quadratics always have 2 answers, and it does? This just happens to be a double root, which means I've got 2/5 and I've got another 2/5. I just don't have to write them both down. Okay, next practice problem we have. Please again, notice that this is not equal to 0. So we have to solve that issue by subtracting our 13. Be very careful how you line these up. So I've got negative x squared, I've got a positive 4x, got a negative 13, and that's equal to 0. Once it's equal to 0, we can identify the A is negative 1. Be careful, that is a 1. B is positive 4, and C is negative 13. As always, we simply fill those in where we see them, and we can finish solving. That leaves us as a negative 4, and I've got 16. A negative times a negative times a negative is still a negative. 4 times 1 is 4. 4 times 13 is 52. All over 2 times negative 1, which is a negative 2, which means I have this. And if I subtract those two, I'm going to get a negative 36 all over negative 2. Well, we remember simplifying our radicals, plus it's a complex number with a negative inside there, so it factors to be a 6 and an I. And that, of course, reduces to a negative 2. Oops, forgot my negative there. That reduces to a positive 2. And 6 divided by that is going to be a negative 3i. But please notice, because of this, it doesn't change anything. So we end up with 2 plus or minus 3i. As I said, we always have 2 answers. They just happen to be 2 imaginary answers. Okay, I am going to show you a U-try problem. As you always do with U-tries, please turn off the video, hit it on pause, solve the problem, do the very best you can. Don't wait for me to solve it for you, and just come back when you had a chance to finish. Okay, welcome back. Let's take a look at what we would do for this problem. I had to move the 7x to the other side. I've got my A and my B and my C. Plugged them into the correct locations, and I ended up with the square root of 17. Now that does not factor like my earlier problems did, which means I'm simply going to leave it like this. Now if you wanted to plug that into your calculator to get a decimal answer, you absolutely could if that is something that you're interested in. I don't particularly care one way or another, that's up to you. Okay, let's go to our next U-try. Same rules, if you would please just write the problem down, do the very best you can on it, and then come back when you are finished. Okay, welcome back, and let's take a look at this. Okay, to get rid of this negative 6x, I have to add it to both sides. So I have my A and my B and my C. Plugging them into the correct locations, I end up with this. Please remember, you guys, that has to be factored. It's 2 times 3 is 24. That means I can pull out a set of 2's, which is where I get this. Those reduce to a negative 3, and those reduce to an I. You can also write 1i if you really want to. Again, squared power, 2 answers, and I've got 2 answers here. They just happen to be imaginary answers. Okay, the last 2 problems that we have are focusing on finding that discriminant, which is actually shorter and easier to do. First thing we do is make sure that it's equal to 0, which it is. Identify my A and my B and my C. This time, remember, we're only using the discriminant, which is b squared minus 4ac. So I'm going to plug in my b squared and my 4ac, and I'm going to see what I end up with, which is 36. Let's see, did I plug those in correctly? I got an A. Oops, nope, that wasn't a negative. Sorry about that, my bad. That should have been a 10. There we go. Easy to make mistakes like that. 4 times 1 is 4, times 10 is 40. If I subtract those, I get a negative 4. That happens to be less than 0. If you will look at that up on the chart that I gave you earlier, less than 0 means I'm going to have 2 imaginary roots, answers, solutions, whichever you would like to call them. I will call them today roots. Please also remember, this is not going to be hitting the x-axis because they are not real. Okay, if you will go ahead and work on your U-try, which is right here. Pause and come back when you're ready. Okay, welcome back. Let's see how we did. We have A is 1, we have B is negative 6, and we have C is 8. Plugging that into b squared minus 4ac. I've got 36 minus 48. Sorry. Try and do that in a hurry. Minus 32. 36 minus 32 is 4. 4 this time, greater than 0. Greater than 0 means I have 2 real roots, or 2 real solutions, or 2 x-intercepts, since they are real. And that's all that's required for those problems. Okay, as always, I hope this made sense. If it didn't, or if you needed some extra help, please make sure you talk to your teacher during tutorial support, which are Tuesdays and Thursdays from 2 o'clock to 3 o'clock. Have a great day. Thanks for listening.